Welcome to another video on the 2022 NECO Physics Practical. This is the second part of our discussion on the optics experiment. In the first video, we analyzed in detail this experimental procedure, and we also talked about the nature of the graph you should expect. If you haven't watched the first video, I highly recommend you do so. In this second video, under optics experiment, I'm going to simulate the experiment using the Mavinhub Physics Lab. Mavinhub Physics Lab is a great application that simulates physics experiments that falls into the optics section, mechanics section, heat, and so on. So I highly recommend you download it so that you'll be able to demonstrate this experiment after watching this video. And if you want to know how to download this software, check the description for details. So let's take a look at the experimental procedure. So the first thing to note is the objective of this experiment is to verify the law of reflection of light using plane mirror. So the idea is we want to prove or show that the angle of incidence is equal to the angle of reflection. If you want to know in detail how we're able to show that, check the first video. So here we have the apparatus. You have a drawing board, drawing paper, meter rule or a ruler from your mathematical set, plane mirror, optical pins, and protractor from your mathematical set. So let me summarize the procedure. The first thing you expect to do is to place your mirror, your plane mirror as described or as shown in this diagram. Then you expect to draw a line that runs through point AB. Then after drawing that line, you expect to remove the plane mirror. Then draw a line that is perpendicular to line AB. So that line is line PQ, and that line is known as the normal to the line AB. The next thing you do is to draw another line that is parallel, that is at 90 degrees to line AB, and that line runs through C and D. So how do you perform this experiment? The first step here is to measure line X. So X is is line AC essentially. So let's say X is 4 centimeters. So you make C to be at 0.4 centimeter away from A. So in other words, you make AC to be 4 centimeters. Then you draw a line that runs from C to Q. Then after drawing that line is your line of incidence, right? Then you position two pins, P1 and P2. Make sure that they are well spaced. So these two pins you mark as P1 and P2. Then on the right side of line PQ, you position your eye and try to look into the plane mirror. So you replace the plane mirror and try to look through the plane mirror. Then what you do is you try to position two pins such that those two pins aligns with whatever you are seeing in the plane mirror. So once you've gotten those 2 points, that's point P3 and P4, you draw a line that runs through points P4, P3, then runs through Q and eventually touches D, right? So the next thing we do is to measure the angle at C. In other words, measure angle ACQ and measure angle ADQ. So ACQ is θ1 and ADQ, angle ADQ is θ2. Then you take the average of those two angles. In other words, you calculate theta, which is θ1 plus θ2 divided by 2. Then the next one you do is to take the tan of theta. So the tan of theta will be calculated as tan theta. Then the last thing you do is to take the reciprocal of x. So you're going to tabulate all of this. You're going to tabulate x, the x reciprocal, θ1, θ2, and theta, then finally tan theta. Then after doing all of that, then you repeat the experiment with a new value of x. But this time around, that will be on a new sheet of paper with a new value of x. Then you repeat the entire process and then record your readings. So once you are done with the readings, you plot a graph of tan theta on the vertical axis. In other words, tan theta will be on the y-axis and x raised by minus 1 will be on the x-axis. Then you'll be asked to determine the slope and eventually asked to determine 2 times the slope. So let's look at the settings. In the settings, we are going to vary x from 1 to 5 using a step of 1, and we are assuming that the length of the mirror is 20 centimeters. So let's start the experiment. So this is the laboratory, the virtual lab environment, and we are going to start our readings from making x to be 1 and up to 5. So how do you change the value of x? You change the value of x by moving the slider, by ensuring that this x is highlighted, and by moving the slider. If you move the slider, the value of c varies in accordance with the value of x. So AC is equal to x. Then how do you get the points? How do you get points P3 and P4? You do that by moving your eye until the blue pin and the orange or orange pin align. Once both of them are exactly aligned with your eye, that's the point where you position the points P3 and P4. So in this case, let's start with when x is 1. So once x is 1, you switch mode to the eye mode. Then you move the slider until you see the 2 pins align perfectly. So once they align perfectly, it shows that once they're in perfect alignment, it shows that you've gotten your P3 and P4 well positioned. Once your eye is aligned with those 2 object pins. So the next thing we want to do is to measure angle, the angle at C and the angle at D. So to do that, you're going to position your protractor right there. And once you position your protractor at both points, you measure the angle. So in this case, I'm going to quickly measure the angle and then move to the next reading. So after taking the reading, the angle theta 1 is 84. It's roughly 84.3. Then theta 2 is also roughly the same thing, 80 is roughly 84.3 as well. Then theta is the same thing, 84.3. You may have slightly different result due to inaccuracy, but you expect to have very similar result. Theta 1 and theta 2 should be very ideally should be exactly the same. But if they are slightly different, that's still acceptable. Then 1 over x is 1. Then tan theta is 10. It's roughly 10. Then the next is to change the value of x to 2. So we're going to move x to 2. And once you do that, we're going to get, so we're going to move x to 2. Then the next thing we want to do is to align these 2 pins so that the blue pin covers the orange one. So to do that, you switch to the eye mode, then you move your eye until you see such an alignment. Once both of them are well aligned, then it shows that the point P and point P3 and P4 are in the right position. So once you have this, the next thing you do is to measure, is to position your protractor to measure angle at C and angle at D. And once you do that, you are going to get the following reading. After taking your reading, you're going to get the following. At x equals to 2, theta 1 is 78.7, roughly 78.7. Theta 2 is roughly 78.7 as well. Then theta, which is the average, is 78.7. Then the reciprocal of x, which is 1 over 2, is 0.5. And then the tan of theta is 5. So the next thing I want to do is to get the reading when x is equal to 3. So you remove the protractor and you repeat the process for x equals to 3. So this is what you do. You move it until you get 3. Then you move your eye until the orange and the blue pin allow until only the blue one covers the orange one. By the time you are looking through the mirror, you should see the blue one covering the yellow one. The one in front should cover the one behind it. So at that point, you can fix your pin 3 and pin 4. So it's roughly here. So if you check, they are almost perfectly aligned. So we can take reading at this point. You place your protractor, you measure the angle at C and the angle at D, and then you take reading. So the reading here for theta 1 is 73, is roughly 73.3, and the other one is roughly 73.3, and theta is 73.3. Then the reciprocal of x, which is 1 over x, is 0.33. That's 1 over 3. Then the tan theta is equal to 3.33. So the next thing we want to do is to get the reading when x equals 4. So what you want to do is to go back to x, then make C, the distance between A and C, to be 4 centimeters. So once you do that, the next thing I want to do is to position your eye and get the new points P3 and P4, and that point is where the pin at P2 covers or aligns with the pin at P1 when looking through the mirror. So you can check properly to see if they are aligned. So I think they are almost perfectly aligned. Okay, so the next thing I want to do is to take your reading. So to take your reading, you insert your protractor. Your reading is basically what you have for this point D, for instance. Your reading is you moving from the base here up to this point. That is, if you look at this angle, is about 70, right? It's almost 70, 60 something. So, but the exact value is as follows. The exact value is 68.2, and this is 68.2. Then the average is 68.2. Then the reciprocal of 1, that's 1 over 4, is 0.25. And finally, the tan of theta is 2.5. For the last reading, we make x to be equal to 5. So you go back to x, then you move it up until you get to 5. Once you have 5, the next thing you want to do is to move your eye until you get the blue pin aligning with the orange pin. So you adjust it carefully until they cover perfectly or almost as perfectly as possible. Then once that's done, you want to determine the angle, right? So the angle here is 60, is almost 65, but not exactly 65, but close to 65. You can see that it's in between 60 and 70. Then you can get more precise information at the top. So it's around 63 points. It's close to 63.5. So almost 64. Okay, so let me write the exact reading. So the exact reading for what I have is 63.4. and here you have 63.4, and the average is 63.4. Then 1 over x, which is 1 over 5, is 0.2. Then tan theta is 2. That's tan 63.4 is roughly 2. So this is our reading for various values of x. So the next thing to do is to plot your graph. So this time around, we are plotting a graph of tan theta against 1 over x. So let's go to the graph section. So making a good graph is very important because it carries a lot of mark. So it's very important you know how to make a good graph. We've made a video on how to make a good graph, and you can check our video on YouTube and other social media platforms for videos on how to make good graph. But here I'm going to quickly go through it without explaining it in detail so that we can quickly see what the outcome of our experiment is. So to make a good graph, you start with the title. So in this case, the title is tan. We are plotting a graph of tan theta. So you can just say tan theta versus 1 over x. Then the x label, you want it to be something like 1 over x because that's what will be on the x-axis. And you specify the unit, which is centimeter raised to the power of -1, right? Then for the y-axis, the label is tan theta. You can write the theta in any, you should write the symbol of the theta. Then the next thing I want to do is to define the range of this graph. So define the range means you want to specify what should be the spacing along the x-axis and y-axis. So to get to know how to do that, watch our video on how to make a good graph. But a quick reminder is this: just figure out the minimum and the maximum that you want to have on this graph, and you have to factor in intercept. If you're expecting to have any negative intercept or so, you have to factor that in. So in our case, we are just dealing with numbers ranging from 1 to 0 to 0 is the minimum we should be expecting on this x-axis, and 1 is the maximum. And the maximum should not be at the very edge, should be somewhere here, right? So by factoring all of this, you take the difference between the minimum and maximum and you divide by the number of division on your graph sheet. But I'm just going to quickly specify a reasonable scale based on some calculation that I've just described. So a reasonable scale for the x-axis is as follows. For the x-axis is minus 0.2 up to 1.2 with a step of 0.2. So as I said earlier, you are not expected to stop at 1 at the maximum because you need to give an extra space. Then for the y-axis, you want to start from -2, then stop at 12 with a step of 2. So this is the scale on the y-axis. Once you are done with that, the next is to locate all these points on the graph. And to do that, you just ask yourself, when 1 over x is 1, tan is 10. So in other words, when on the x-axis, when we have 1, on the y-axis, we have 10. So you just draw your star or your dot or whatever indication you want to put here. But on this software, to locate your point, you have to click on this pencil sign on graph point to indicate that you're about to indicate your point. So here I'm going to click to indicate the first point. Then for the second point, where we have 0.5, we have 5. So 0.5 is just at the middle here. Then here we have 5, which is just at the middle here, right? So you just click. Then the next is when we have 0.33, tan theta is 3.33. So where we have 0. This is 0.3 is just at the middle here. The 0.33 is a little bit close to this edge, right? Then on this side we have 3.33, which is somewhere. So this is 3.33 somewhere here. So we have 3.33. Then the next is 0.25 and 2.5. So 0.25 is somewhere here. This is 0.2. Then the next step is the difference between 0.5 and 0.2 divided by 5. So which will give us, so this tiny step is 0.4, right? 0.04. Then 0.25 should be very close to that. So somewhere here. Then this is 2.5. So 2.52 should be very close to this point. So this is 2.5 here. So the next is to get the last one done, which is 0.2 and 2. So this is 0.2 and this is 2, just right here. So now that we've gotten all the points on the graph, the next is to draw the line of best fit. The line of best fit should be a line that runs through all this, as many points as possible on this graph. So let's say I decide to start from here. My line of best fit should run through as many points as possible. So this is my line of best fits. So the next thing I want to do is to get the slope done. So to get the slope done, you click on this pencil that you're about to get the slope done. Then you'll be asked to pick 2 points. So I'm going to pick this particular point and I'm going to pick, let's say, this point. Let me start again. Let me clear and start from here. Let me pick this one first. Then let me pick this one next. You can pick any point on the line of best fit. Okay, so what is the x1 and y1 and y2? So y1 is the value on the y-axis for this first point, and y2 is the value of the y of the tan theta on this other point. So y1 is, this is point 1, this is point 2, so y1 is 2 and y2 is 4. Then the difference between y2 and y1 is 2. That's y2 minus y1 is 2. So here we have 0.2 as x1. Then x2 is 0.4. If you take the difference between x2 and x1, you get 0.2. Then we divide 2 by 0.2 and that will give us 10. So the slope is equal to 10. So so we are done with the graph basically, and this is how you plot a very nice graph for this experiment. So the next is to answer some questions. You might be asked to answer some questions. So in this experiment, we are asked to multiply the slope by 2, and that is actually the length of the mirror. So 2 times the slope, which is 2 times 10, will give us 20. Then for the next question, the image formed by a plane mirror is real. So this question is asking us, can we say that the image formed by a plane mirror is real? The answer is no, because a plane mirror forms a virtual image, not a real image. So the answer is no. Then an object of 10 centimeters is placed in front of a plane mirror. What is the height of the image that is formed? So for a plane mirror, the image height is equal to the object height. So since the object height is 10 centimeters, the image height will also be 10 centimeters. So once you are done with your experiment on this application, you click on submit. Then once you submit, you get to see how you perform in various aspects of the experiment. So in this experiment, you get to see how you perform in the reading section, in your ability to plot graph, in your ability to locate points on the graph, your ability to draw line of best fit, and also your ability to determine the slope and how you perform in the question section. So you also get to see how much time you spend in each part of the experiment. So this is the results of this experiment. Here's my graph, and here's the graph um, generated by the computer based on the setting and on this experiment. And here's my performance under the question section. So if you wish to practice more, if you also wish to change the length of the mirror and see how the result plays out, you can do that and get a different result or a slightly different result and gain mastery of this experiment.